Alright class, in this lesson we're going to take a look at graphing exponential functions. And we've got two exponential functions sitting right here. We're going to graph this y equals 2 to the x power first. Now these are in the form f of x equals ab to the x. Now a is generally the number that's in front of the base that's being raised to a power. The base, that's the b, being raised to a power, the x. So in this first equation it's y equals 1 times 2 to the x power. So the 1 is the a, the 2 is the b. Now what the a is, the a is where it crosses the y-axis. So crosses the y-axis before any shifting. So, for example, this first problem, it was going to cross at 1. So that's pretty much the only helpful bit of information we have. Now it was going to shift left to right, but that's based on any numbers that's up in the exponent. There's none up there, so this one's not going to shift left to right. So it does start at 1, and then the 2, the base, tells you the degree to which this thing is exponentially increasing or decreasing. If it's a whole number like 2, it's going to be an exponential growth. If it's something like 1/2, this is a decay. Okay, so this one is a growth. Now the way you know it's a growth is if it's a number that's bigger than 1. So if that b is bigger than 1, you get a growth. If it's between 0 and 1, it's a decay. Okay. Now, to actually figure out what coordinates go on the graph other than just 0, 1, we should make a t-chart. And our equation again is y equals 2 to the x power. So we're going to plug in -2, -1, 0, 1, 2. Well, we already know that 0 is going to be at 1, but you can plug it in anyway. Sorry, this is supposed to be 2 to the x power. So we can plug in our 0, and you'd get 2 to the 0 power, and anything to the 0 power is 1, and that's why it was 1. Okay. Now let's plug in the other ones. So -2. So 2 to the -2 power is really the same thing as 1 over 2 to the second, because if we have a negative exponent, it needs to move to the bottom. And 2 to the second is 4, so it's 1 over 4. So this is 1/4. Now if we have 2 to the -1 power, it's going to be 2 -1. So that's going to give us 1 over 2 to the first power, which is just 1/2. Okay. Now if we have 2 to the first power, it's just 2, and then 2 to the second power would be equal to 4. So if we were to plot these points, -2, we go up a quarter. So we go up a quarter right there, and then at -1 we're up at 1/2, and then at 0 we're at 1 like it was, and then at 1 we're at 2, and then at 2 we're at 4. What you're seeing happen up here on the graph, if we connect the dots, this is going to be a nice curve. Okay. Now it actually continues to shoot up very rapidly, like so, and then it would continue to get closer and closer to the x-axis without ever actually touching it. So it looks like, it's touching, but it'll actually get closer and closer forever, but it'll never actually touch the x-axis. And that's called it's a horizontal asymptote, but it's an asymptote. We would put a dotted line there if you wanted to show that it never actually crosses the x-axis. See, it's closer and closer forever. Okay. So you can see what I did was I made a t-chart, I plugged the points in, and then I went ahead and plotted them on the graph. Okay. Well, we're going to do the same thing for y equals 1/2 x. So let's go ahead and make our t-chart, and we'll use the same numbers: -2, -1, 0, 1, 2. Okay. And when I plug in -2 this time, it's going to be 1/2 to the -2 power. And notice I put it in parentheses. That's because I need to flip my 1/2 and make it 1/2. Give myself some room. So it's going to flip and make it 2 over 1 to the positive second power, which is just 2 to the second power, which should be 4. So this first one is 4. And then if we take 1/2 and raise it to the -1 power, it should flip this and cause it to be 2 over 1 to the first power, and that is 2. And then if we take 0 0 to the negative 2 power is going to be, sorry, I didn't mean to the negative 2 power, I meant 1/2 to the 0 power. Anything to the 0 power is 1, so that's where we get a 1 right here. And then we get 1/2 to the first power, which is just 1/2. And then 1/2 to the second power is 1/2 times 1/2, which is 1/4. Okay, so now I just have to plot these points up here on my grid, and I should get negative 2, 4, put a dot there, negative 1, 2, 0, 1, 1, 1/2, and 2, 1/4. Now if I connect my dots here on this grid, I should end up with a nice curve going the other direction as the last graph. And as I said before, if it's a 1/2, this is an example of a decay, because as you notice from left to right, the graph is getting lower, and then the other one was a growth, so this one was a growth, because from left to right, it was going up. Okay. Now what happens is we actually get to shift these graphs. So let me erase. The original y equals 2 to the x should have been a graph that just looks something like this. Okay. Now what happens is sometimes we'll get y equals 2 to the x minus 3. Now what happens is this kind of like the parabolas. This is kind of like parabola when it was inside the parentheses squared. We move left or right opposite of the sign. Same thing happens here. We actually take this same graph and it shifts to the right opposite of the sign, right 3 places. So it's like it goes 1, 2, 3 places over. Same graph, just 3 places over. Looks like that. So that would be if it was without the square, of course. Y equals x minus 3. Sorry, 2 to the x minus 3. So it just takes the same graph and shifts it to the right. Now let's say I had like a plus 5 on the outside, which is possible. It would be this blue graph shifted up 5. So I go up 1, 2, 3, 4, 5. And it would be an exponential graph that looks like that. So this green graph would be this y equals 2 to the x power minus 3 plus 5. Okay? So you'll have some shifting. You could, if you did a t-chart, you would end up with this graph that I just did, but if that made any sense to you, that would actually make your life easier when you go ahead and try to graph these in the lab. So let's take our 1/2 x and let's put a plus 3 and then put a minus 2 on the outside. Well, we had our 1/2 graph, which should have been something like this, okay? And basically we're just saying take that same graph and move opposite of the sign, so negative 3 places, 1, 2, 3, and then move it down 2. So now this point just basically got translated right there, so this graph is now right here. Okay, so that's translating exponential graphs. They shift and move just like the absolute values and just like the parabola graphs we had a few lessons ago. Now sometimes they get a little more complicated, like this particular problem. And now what's happening is this is an exponential graph of the base of 3. So there's still a 1 in front, which means my initial point would have started at 1, and then we're timesing it by 3 now. So, sorry, backing up, this 1 right here, this would be if it was y equals 3 to just the x power. Okay? If I was to graph just this, what would happen is I would have 1, I could do a t-chart like I was doing before, and do negative 2, negative 1, 0, 1, and 2. And if I plug those in, I would get 3 to the negative 2 power, which would be 1 over 9. I get 3 to the negative 1 power, which would be 1/3. 3 to the 0 power, which is 1. 3 to the first power, which is 3. 3 to the second, which is 9. So if I was to plot these, it would look very similar to that y graph. It would just be a little smaller there, 1/3 here, 1 here, 3, and then it goes up much steeper to 9. Okay, so same graph does something like this. So now what happens is it's like we see this, it adds this 2x minus 4. Well, we're not moving to the right 4. where actually it's kind of like, if you remember the absolute values, where we're not supposed to have this 2 just hanging out right here. It's kind of like there needs to be a 2 factored out of those two things, so it's kind of a 2 in parentheses x minus 2. So if it doesn't make sense, it's fine. I'm going to make a t-chart, and it's really simple in a second. And so it's basically this graph shifted to the right 2, so this point right here is going to now be right there, and this graph just gets steeper because this 2 in front makes it taller. But anyway, backing up, if we were just to do a t-chart with this graph, which is the easiest way to approach it, I just wanted to extend what I was talking about with the shifting graphs. We have, let's just put in there negative 2, negative 1, 0, 1, 2, 3, 4. Now the reason I'm going all the way over to 4 is because I know that the graph is going to shift to the right. Because usually, and that's why I showed that last slide where we saw the shifting graphs, usually what I have students ask me is, well, how did you know where you should use your t-chart? Because sometimes you start doing a t-chart and all you're getting is a graph that looks like that, and you're not getting the rest of it. Or in this case, you would get a graph that looks like this. Because as we plug in these first two values, they're not going to be very meaningful. In fact, the 0 is not going to mean very much. It's going to be these really, really small things, and we're not seeing anything until we get to 2 and we finally see something happen. Okay? So how do I know is that it's shifting here. Okay, and that's why I try to explain that it does this thing up here in the exponent. It helps you pick the points for your t-chart. So like I said, it does shift to the right, which means I'm not going to plug these values in. I could plug in 0, and if I plug in it at 0, I'm going to get 3 to the 2 times 0, which is 0 minus 4. So it's really 3 to the negative 4 power, and that's a really small number. It's really not even valid to graph, or not important to graph. So I'm not even going to graph 0. So let's plug in 1. So it's going to be 3 to the 2 times 1 minus 4. So now I got 3 to the negative 2 power. Okay, now I'm looking at 1/9. Okay, now that's a more reasonable number. Now I've got to the second power, so this is going to be 3 to the 2 times 2 minus 4. So it's basically 3 to the 0 power, which is 1. And then now I can go ahead and plug in my 3. So it's 3 to the 2 times 3 minus 4. So that's going to be 3 to the 6 minus 4, which is 2 power. So this is now 9. And then we'll do one more, and we'll do 3 to the 2 times 4 power minus 4. And that's 8 minus 4, so it's 3 to the 8th minus 4, which would be 3 to the 4th power. And that is going to give me 81. And obviously I'm not going to graph 81 on this particular grid over here. So as you can see, I can plot these points now. At 2 I'm at 1. At 3 I'm at 9. And then at 4 I'm way up high. So what you can see is my graph, it comes along really, really slow, and then it just shoots straight up. And it's even steeper than what I just drew, because by the time I get to 4 I've got to be all the way up at 81. So like I said before, it shifted, and the graph, instead of being at 1, it shifts actually over to 2. 1 is the coordinate right here. And then it's much, much steeper than the original graph I was showing you with just the regular y equals 3 to the x power. Okay, so easiest way, t-chart when it gets more complicated like this. But when it's something smaller like this, you might be able to just shift these two graphs, because a lot of them have to do with 2 to the x and 1/2 to the x. Okay, otherwise a t-chart does you very good going from -2 to +2.